All right, today, properties of rational exponents. So we're going to talk about a couple things here. We have the product property, quotient property, and then adding exponent property, okay? So again, we're doing radicals. This little weird looking house thing is called a radical. Product property simply just states if you have two square roots with the same index, okay, and you're multiplying them, so if I had an A and a B inside these two houses here, I can just multiply them together because they're from the same index. It's kind of like terms of the radical world, just as in quotient property, right? And we can rewrite them both ways. They go forwards and backwards. If I have a fraction, A and a B, all underneath a square root or a radical sign with an index, I can divide that up, right? I can just take this A, put it on top with that radical and index, and I can put the B on bottom with that radical and index, and it still means the same thing. And just like if I had from the right side, I can just divide them together, have fun. You'll see when we do some examples. And finally, adding exponent properties, we're just gonna jump right into those, and you'll see just learning by doing. So let's just jump right into this. First things first, simplify the expression. We're gonna do a couple things here. One, I got the cubed root of 12 times the cubed root of 18. Again, they're both radicals and they have the same index, 3 and 3. Because of that, I can actually multiply these two together. So what I can do is put them under the same house. So the index is 3, so the cubed root of, and I can do 12 times 18. Now, I could use my brain for that one, obviously. 12 times 18 is 216. Now, even though we're done, we just took care of the rule, because that's what the rule is stating. That is the product property of rational exponents. We are going to try to simplify this. I want a number. And so to do that, we're going to use our handy dandy calculator. Now, you guys, if you guys been looking around a calculator lately, you'll notice that we have a square root button, right? But there's nowhere we can put a cube root in, at least not to my knowledge. So in order to figure this one out, we're going to utilize the skill we did last video. Or not last video, but earlier. I'm going to rewrite this as 216. And remember, my index over here is 3. Remember, this 216 is to the power of 1 technically. And if I want to rewrite this radical as an exponent, the 1 goes on top, the index goes on bottom, and it's kind of like a fractional exponent right there. So 216 to the 1/3 power is actually the same thing as the cubed root of 216. It's just a way to rewrite it. And now that is something I know how to type into a calculator. I turn my calculator on. I type in 216, caret key. I'm typing in a fraction, so I'm gonna use parenthesis. 1 divided by 3, and parenthesis, and there we go. Hit enter, and we have 6. That is my final answer. Even though this is what we're working on today, and this is correct, I just took a couple steps further to get the actual final answer right here. So I want you guys to try this one on your own. Go for it. All right, guys, so let's see here. So again, I have both these are fourth roots, right? So I got both of these are radicals. I don't care if the numbers inside are the same or not, but the indexes are the same. That's what I look at. So kind of like terms of the rational radical world, I guess you would say. So I can actually multiply 25 times 25. That gives me 625 inside the house here. Again, if I want to find out what this actually equals, even though this is a correct answer, I can't really use my calculator like that, so I rewrote it. So remember, my index is 4. That number now goes on bottom in my fractional exponent. This is to the first power. That's the 1 that goes on top of the fractional exponent. That's how I, did that. And I typed in my calculator. 625 to the 1/4 power, and I got 5. Again, they're both radicals. In this case, we don't always write them down, but that's when there's nothing there, the index is 2. So it's the square root of 2 times the square root of 8. Well, they're kind of like terms of the radical world, so we can just put them under the same house. And I could do 2 times 8, which is 16. Now, even though I have a button for this, right? We know we have a button for square roots on here. Type that in first. Type in 16, hit enter, and we get 4. Or if you guys like it the other way still, if I want to switch this to a fractional exponent, my index, my power to 16 is 1, index is 2. 16 to the 1/2, same thing, 4. Either way, you get the same answer, guys. And that's it. That's all you gotta do for these. So if you have, like radicals, I guess you'd call them, you can actually multiply those together to get one big one, and then you can just simplify it using a calculator. That simple. Quotient property. So let's do some examples. Notice how I got a fractional radical right here, right? Well, I noticed that they're the same. The index of this square root is 4. The index of this radical is 4, right? So I can actually go ahead and just put them under the same one and just divide this, right? Instead of multiplying like I did up here, fraction means division. So here we go. And I gotta find out what is 80 divided by 5. Well, 80 divided by 5 is 16. And there we go. I carried out my rule, guys. It's that simple. And now to figure out exactly what this is going to give me, I can rewrite this as 16 to the 1/4, again, because the 1, there's 16 to the first power, that number goes on top. Index is 4, that number goes on bottom. I now have it rewritten to exponent form. And I can type that in, 16 to the 1/4. I'm just doing, I just type in parentheses, 1 divided by 4 parentheses. Hit enter, 2. Now, with that said, I want you guys to try these two on your own, okay? Take care of it. They both have matching looking like radicals. Take care of division, simplify it. I speak less. Go. Okay, guys, let's check our work. So, 54 divided by 2 gives us 27, and it's underneath the house, a radical to the index of 3. And then we're done. That was you carrying out your rule. But, well, we're shaking my thing. But if I want to find the actual answer, I can rewrite this as an exponent fraction. My power of 1 on top, index on bottom. I typed it into my calculator, 27 to the 1/3 power, gave me 3. Done. This one, 400 divided by 4 is 100. I got my square root sign. It's square root because the index is 2. If I want to rewrite this again, this is to the first power. That's where the 1 comes from. Index is 2. That's where the 2 comes from. 100 to the 1/2. 100 to the 1/2 power, 10. And I'm done. That's it, guys. That simple. Let's jump into our last tab. Applying exponent properties. So, is that what it says? Yep, applying exponent properties. So, when we're multiplying, if you guys remember exponents, like bases, you can add your exponents together. But in this case, we got some fractions. So, let's just jump right into it. I have, and I gotta make a mistake here, guys. This is supposed to be 1/5. Ralph made this mistake, so you can make sure you yell at her a little bit, because usually she doesn't make mistakes, and we can't let her live this one down. So please bring it up to her, make her feel bad about it, because, yeah. It's supposed to be 7 to the 1/5 times 7 to the 2/5. Well, the bases are the same, 7 and 7. So when you have bases of the same, or they're both numbers, I guess you would say, I can go ahead and I can add these together. So this is gonna be 7, and then it's gonna be 1/5 plus 2/5. I can add my exponents. Now this one's kind of easy because the fractions have already a common denominator of 5. So it's just gonna be 7 to the 3/5, because 1 plus 2 is 3. Your denominator stays the same when you add, like, denominators, and we're done. That's that simple. We're not gonna evaluate that. That's all we're getting for this one. Over here, we have, looks like, this is gonna be interesting. We got to change this. I'm actually going to do our power to a power rule, meaning this. So here we go. I have an exponent to a power raised to another power, so I can multiply my powers. So it's gonna be 6. Now, 1/3 times 2. Well, it's like 2 over 1. You guys should remember this from a previous foldable. You top times top, bottom times bottom. So 1 times 2 is 2. 3 times 1 is 1. I'm sorry, 3. 1 times 2 is 2. 3 times 1 is 3. And there we go. Times 4. Multiply it over here, right? 2 times 1 is 2. 3 times 1 is 3. And that's it. Look at that. I just distributed my powers. I'm not going to worry about actually evaluating these out, okay? And plus, these are not like bases, so I can't really add my exponents there like I did over here. And so I'm done. That's all I can do, guys. And then finally, for my last example, this is supposed to be 5 to the 2/3 power. Again, Ralph is just making mistakes all over the place in this foldable. I am dividing exponents of the same base, so I can subtract my exponents. So it's going to be like me saying 5 to the 2/3 minus 1/3. Well, Again, my denominators are the same of common denominators, so it's easy. 2 minus 1. 2 minus 1 is 1. Keep my denominator the same. We are done. 5 to the 1/3. And that's it, guys. Okay? Now, I agree. Radicals, exponents, sometimes it might be a little confusing. Practice makes perfect. Rewatch this. Try to practice on your own. Learn the patterns that you see. You will be fine, I promise. So, stay healthy, stay safe. You guys have a great day.